Hi, I'm Chris Mattock, designer of the Harmony House.
After the backfilling, we achieved one milestone. That means we finished the substructure. So we start the superstructure. So the first thing we are going to do is the framing. So in the coming 2 months, we will concentrate on framing. And during this period, I think the framing crew will be the only crew that working on site to frame the house.
The reason I'm using engineered wood on this project is that the building itself is very unique design by the architect and has a lot of open space and tall roof structure. And the roof itself is not only a snow load or rain load to carry, but also renewable energy equipment, which is the PV panels and the solar energy panels, which gives the extra load on the roof. And on top of that, the materials of the roofing is quite heavy as well. And wind load, we take the kind of wind towers in the roof structure. So we need a kind of very stable beams and the columns. So I picked the engineered wood, which gives a very strong elements and has a lot of stability. It's very precision. There's no cracks or any shrinkage, which gives a very stable conditions.
Engineered wood is used to describe a number of wood products that have been designed and developed for various construction applications. Common examples of engineered wood products include plywood and oriented strand board, known to many as just OSB. The engineered wood products used in the Harmony House include parallel strand lumber, wood eye joists, open web trusses, and plywood. These products tend to use wood fiber more efficiently than dimensional lumber, allowing them to span greater distances and carry higher loads. The Harmony House uses open web joists and wood eye joists in between floors because they allow for easy access for running plumbing, ductwork, and wiring. The wood eye joists in the ceiling are also deep enough to contain the high insulation levels needed for this home. Parallel strand lumber has been used for the beams and posts to carry the heaviest loads, and plywood has been used for wall and floor sheathing because of its strength and durability.
Okay, so what we're seeing here today is the first floor going up, and as you can see, the walls are framed with the studs at 24 inches on center. That's a wider spacing than usual. And you'll also notice that over the windows we're using parallel strand lumber or laminated veneer lumber. And typically the studs are notched on either side of the windows, and we don't have double studs on either side of the windows, which is typical. So we're doing a whole series of things in the framing of this first floor to minimize the amount of lumber. We're probably saving 15 to 20% of the amount of lumber we'd normally have, and that lumber in turn is being replaced with insulation. So we're going to end up with a wall that's resource efficient in that it uses less lumber, and it's also more energy efficient in that it has more insulation in the wall cavities. Another feature of advanced framing is what we call a two-stud corner. Typically in wood frame construction, what we'll see is 3 studs used in a corner. So there'll be another stud here to back up the drywall. But in this case, we're using just 2 studs, and this allows us to get the full insulation in this corner. And then to support the drywall, what we use are things called drywall clips, which are fastened to this stud, and they catch the drywall rather than having a piece of lumber here to catch the drywall. So again, that reduces the amount of lumber and allows us to get more insulation in that area of the wall. So what we see here, Harry is putting caulking on the plywood subfloor, and what that will do is when the wall is assembled on that subfloor, it will provide an airtight seal between the subfloor and the bottom plate of the wall. So now what we're going to do is go down to the basement and see how the main floor is framed, okay? Okay, so here we are in the basement of the Harmony House project, and if you look up at the ceiling, what you'll see is that the main floor here above the basement has been framed using what are called open web joists. And the open web joists, in fact, are made of 2x4s, so it's actually very small dimension lumber, but by turning it into a truss, we can span a very large distance. So it's an efficient use of materials. The other advantage that we get with an open web joist is that we can run services through the joist space. So we can run heating, ductwork, we can run plumbing, we can run electrical wiring through the floor structure. One interesting aspect of this wall assembly is that the wall assembly actually was modeled using a program which not only predicts the heat movement through the wall, but it also looks at the potential for moisture accumulation in the wall. And what that computer simulation program told us is that there was a possibility for moisture to occur in the wall sheathing of the north wall. And this is simply because the wall is so highly insulated and such little heat will pass through the wall that there will not be much of a drying benefit from heat loss through the wall. Also, being a north wall, it never sees any sunshine to help dry it out. So what the building envelope engineers have advised us to do is to use preservative-treated plywood on the north wall to prevent the possibility of that moisture causing any kind of mold growth or rot in the sheathing.
Sealing all the gaps and cracks in your home with caulking and weather stripping is one of the most cost-effective ways to keep heat inside your home. This quick tip has been shown to reduce heat loss in the average home by up to 10%. Here's another tip. Use approved gaskets and electrical outlets to control air leakage and keep heating and cooling costs to a minimum.
Yeah. Everything's ready.
Morning, Harry.
Morning.
How are you?
Good.
What are we doing here today?
Today we install the beams, so wait for the plan, and I just get everything ready and check out the size and think about the detail.
Yeah, 2 pieces of 25 footer, 1 piece of 20 footer, 20 foot, yeah. Yeah. That's for the other 3 beam, yeah. Yeah, okay. Okay, thank you, bye-bye. Hi.
What did you just do there?
Oh, it's top with the thick lumber and ask them to take more protection wrap, because after we hang the PSL, we have to wrap it and protect for weather. Yeah.
Everything on schedule?
For today, yes.
Look at those beams. Jeez. Oh, we should just do this ourselves.
We got enough guys here. We could probably just lift it up. Hey, Chris?
2 floors. Look at these things. Jeez.
We have to hire a crane, a 40-ton crane, to lift this beam into position. Because this beam is 2,500 pounds.
Hi, I'm Tony from Eagle West Cranes. I'm here today to lift 5 or 6 beams. We're going to lift them about 80 feet out, and they're about 2,500 pounds, so pretty easy one today.
My name is Choi. I work with Dick's Lumber and Building Supplies in Burnaby, British Columbia, and I'm just out here today at one of the job sites we are supplying currently with this new sustainable green building that's going to be the wave of the future going in for building across Canada. And we're proud to be helping out and sponsoring some of the materials that are going into this project. One of the reasons I'm out here today is to learn as much as I can going forward so I can pass that knowledge on to future customers that look to do this type of building in the future.
So we were so lucky, we have really good weather. Today's weather means saying that it will be 60% chance of rain. So we have prepared to work up in rain, but in the last 2 hours we have sunny sky. And now the cloud coming in, so we are quite lucky. Yeah, good.
Another day of the job. That's all.
So tell me, what do you do in your spare time?
Curling. Curl with 3 other guys. We're a team on the World Curling Tour across Canada.
So what's the most important part of the game?
Communication.
Yeah?
Yeah, by far.
It's not the throw of the rock.
No, because there's always four components to every shot. Your thrower, both
Yep.
sweepers, skip calling the shot, and yeah, for every shot, every element of the game, one guy's reading the type of ice that we're on, if it's a fast sheet or a slow sheet, how much it's curling and stuff, and it's communication from the thrower to the sweepers to the skip to make every shot. So it's an ongoing battle on every new ice surface run, and when you play the best in the world, that can hand you a loss at any given time. It's a very highly communicative sport.
Yeah.
A lot of core exercise too.
Okay.